I made this really cool display for an Amethyst Orb, and today I want to show you how I made it. I bought this nice polished ball of amethyst when I was on a visit to Colorado a few years ago. I thought it looked really cool, and I wanted to come up with a nice way to display it. I wanted to create a display that showcased the patterns and let you see them from different angles. The orb's rotation is driven by two rubber wheels hidden underneath the casing. When the wheels spin in the same direction, the orb's axis of rotation is parallel to that of the wheels. When the wheels spin opposite to each other, the axis of rotation of the orb is perpendicular. And when the wheels have different relative speeds, the axis of rotation of the orb is somewhere in between. I printed out the physical pieces on my ender. This part will hold the motors. These are the top and bottom cover plates to hold everything inside. For this project, I'm using the pictured wiring diagram. The display is powered by a USB-C port, either charging the battery or directly powering the motors. The switch on the positive output line turns the entire display on or off. Motor speed is controlled by the twin motor boards, while directionality is commanded by a switch mounted between the board and the motor. Because space is at a premium, since I'm trying to keep this as small as possible, I am desoldering components from the motor control board so that way I can lay them flat and then mount the potentiometers in a more convenient location. Here I'm soldering jumpers to the potentiometer. And now I solder the other ends of the wires directly to the control board. And I do the same for the capacitor on both boards. Now I solder the battery onto the battery terminals of the power board. Now I'm applying Kapton tape to the backs of the boards so that way I can prevent any electrical shorts. And after the tape has been trimmed to size, the boards are ready for installation. Using the wiring diagram as a reference, I solder the wires running from the switches to the proper terminals on the motor control boards. I currently installed jumper wires for one of the potentiometers were actually too short, so I need to cut new ones and resolder. Now it's time to solder the main output lines to the power board. The negative terminal connects directly to the negative terminals on both speed control boards. The positive terminal connects to a switch that is located on the underside. For whatever reason, only one of the speed controller boards was controlling speed. The other one was working perfectly fine. I poked around with this for quite a while. I tested a lot of the joints with my multimeter. I soldered and desoldered some components, and I even tried swapping out some stuff. I was worried that I might have fried one of the speed controller boards. Nothing ended up working. I may come back to this in the future, potentially with a new board, but I'd already spent a fair amount of time working on this, so I decided to just keep going with only one of the boards. My initial rollers were printed out on my ender out of TPU. They weren't perfectly circular, and they weren't very grippy, so I decided to make them out of a different material. I took the rubber out of a rotary tool sanding head and cut it in half. After failing to get a nice even surface freehand, I tried fixturing a little bit better. I wanted it to be perfectly round, so I also mounted it in my rotary tool and tried using some sandpaper to even out any bumps or irregularities on the surface. This ended up working okay-ish, but I still came up with a better solution. Printed out the pieces that would secure the rubber bits, the motor shafts, and then glued them in place. Then, with a diamond burr mounted in the rotary tool, I mounted each wheel onto the motor and carefully walked it into the path of the rotary tool. This caused the rollers to become perfectly cylindrical and concentric with the axis of rotation of the motor, meaning that I wouldn't have to deal with any skips or jumps in the contact with the ore. And now doing initial testing, I can see that it moves perfectly smooth. Not a single skip. For the cover, I wanted to try matching the appearance of the amethyst. I took some alum crystals that I'd grown previously and glued them onto the cover. These will be the seed crystals that will grow into a layer of crystal that covers the entire surface. I made sure to cover it as much as I could since I wanted this to be very irregular and jagged to contrast the polished ball. Next, I poured more alum into some not quite boiling water. Boiling the water raises the saturation point, which means I can put more alum into it than you would be able to at room temperature. So as it cools, it'll deposit that as crystals. It's a really easy way to grow them quickly. I used some fishing line in my helping hands to suspend the seed crystals in a vat that I then filled with the alum hot water mixture, and then added in some purple dye to match the amethyst. Then I let the crystals grow in my kitchen for the next day and a half. After the crystals had grown to encompass the cover, I took them out of the bath and let them dry fully. Off camera, I gave them a coating of lacquer to protect them from any moisture or accidental spills. And now it's time to install the cover and do final checks before the glamour shots. So you can see that one potentiometer doesn't change the speed at all. When turning it, it doesn't affect rotation. However, as I turn the other one, you can see how it alters the path that the ball takes as it revolves. Each side switch flips the directions, and the central switch turns the entire thing on and off. Thank you so much for watching. I hope you found this informative, if not entertaining. Hope to see you back here again. Please like and subscribe so that way you don't miss an upload of a new video. I'm glad to be coming back with more cool projects like this. But until then, thank you again for watching, and have a wonderful day.